Hello, my name is Austin Bingham. Welcome to the 10th module of the Python Fundamentals course. Here we'll cover some topics related to producing working, maintainable code in Python. We'll look at the unit test module, which you can use to automate testing of your code, and we'll look at the debugger that comes with the standard library. After that, we'll briefly cover the basics of packaging and distributing your code, as well as how to install third-party packages. When we build programs of even minor complexity, there are countless ways for defects to creep into our code. This can happen when we initially write the code, but we're just as likely to introduce defects when we're making modifications to it. To help get a handle on defects and keep our code quality high, it's often very useful to have a set of tests that you can run which will tell you if your code is acting as you expect it to. To help with this, the Python standard library includes the unit test module. Despite its name, this module provides a flexible framework for automating tests of all sorts, from acceptance tests to integration tests to unit tests. Its key feature, like many testing frameworks in many languages, is that it makes automated and repeatable tests, meaning that you can cheaply and easily verify your code at any time. The unit test module is built around a handful of key concepts. At the center of these concepts is the notion of a test case, which groups together a set of related individual test functions. A test case is the basic unit of test organization in the unit test framework. The next important concept is that of fixtures. Fixtures are pieces of code which run before and/or after every test method. Fixtures are used to make sure that the test environment is in an expected state before a test is run, for example, to create a necessary database table or populate a cache. Fixtures are then used to clean up any resources that may have been used in a test method. The final key concept is that of assertions. Assertions are how you can tell the unit test framework to make specific checks which determine whether a test passes or fails. Among other things, assertions can make simple Boolean checks, perform object equality tests, or verify that the proper exceptions are thrown. If an assertion fails, then a test function fails, so assertions are really the lowest level of testing you can perform. With those concepts in mind, let's see how to actually use the unit test module. For this, we'll use test-driven development to write a simple text analysis function. This function will take in a file name, read the file, and calculate both the number of lines in the file and the number of characters in the file. Since this will be an iterative development process, we'll put the code in the file textanalyzer.py rather than work at the REPL. So to start, let's create our first test with enough supporting code to actually run it. First, we import the unit test module. Next, we create our test case by creating a class, textAnalysisTests, which derives from unittest.testCase. This is how you create test cases with the unit test framework. To define individual test methods in a test case, you simply create methods that start with test underscore. These are automatically discovered by the unit test framework and don't require any sort of explicit registration. In this case, we define the simplest possible test. Does the analyzeText function run at all? This function doesn't make any explicit checks, but rather it relies on the fact that a test method will fail if it throws any exceptions. So in this case, if analyzeText isn't defined, then this test will fail. Finally, we define the idiomatic main block, which calls unittest.main when this module is executed. Unittest.main will search for all test case subclasses in a module and execute all of their test methods. Since we're using test-driven design here, we expect our tests to fail at first, and indeed, this fails spectacularly for the simple reason that we haven't defined the necessary function yet. Unittest.main produces a simple report telling us how many tests were run and how many failed. It also shows us how the tests failed, in this case showing us that we got a name error when we tried to run the non-existent function analyzeText. Let's fix that by adding the function. Remember that in test-driven development, we only write enough code to satisfy our tests, so all we do now is create an empty function. Running the test again, we find that we now pass. The next thing we want to do is to be able to pass a file name to analyzeText so that it knows what to process. For this to make sense, we want the file name to represent an actual file. To make sure that a file exists, we're going to define some fixtures. The first fixture we can define is a method on the test case called setup. This function is run before each test method. In this case, we'll use setup to create a file for us and remember the file name as a member of the test case. The second fixture available to us is another test case method called teardown. Teardown is run after each test method, and in this case we're going to use it to delete the file we created in setup. And since we're using the OS module in teardown, we need to import it at the top of the file. Notice how teardown swallows any exceptions thrown by os.remove. We do this because teardown can't actually be certain that the file exists, so it simply tries to remove the file, and it assumes that any failure is acceptable. With our two fixtures in place, we now have a file that is created before each test method and which is deleted after each test method. This means that each test method is starting in a stable, known state. This is critical to making reproducible tests. You may have noticed that the setup and teardown function names aren't in line with what PEP8 prescribes. This is because the unit test module predates those parts of PEP8 which specify the convention of function names being in lowercase with underscores. There are several such cases in the Python standard library, but most new Python code follows the PEP8 style. Now that we have a file name that we can pass to analyze text, let's pass it in by modifying our existing test. Since the self argument passed to the fixture is the same instance as that passed to the test methods, our test can access the file name attribute created in setup. Of course, this test fails because analyze text doesn't accept any arguments yet. That's simple enough to fix. And now we're passing again. Now that we're satisfied that the function exists and accepts the right number of arguments, let's see if we can make it do real work. The first thing we want is for the function to return the number of lines in the file, so let's define that test. Here we see our first example of an assertion. The test case class has many assertion methods, and in this case we used assert equal to check that the number of lines counted by our function is equal to 4. If the value returned by analyze text is not equal to 4, this assertion will cause the test method to fail. And that is precisely what happens. We can now see that we're running two tests, that one of them passes and that the new one fails with an assertion error. Let's break from the TDD rules and move a bit faster now. First, we'll update the function to return the number of lines in the file. And this gives good results. So let's add a test for the other feature we want, which is to count the number of characters in the file. Since the function is now supposed to return two values, we'll have it return a tuple with a line count in the first position and character count in the second. Our new test looks like this. And it fails as expected. This tells us that it can't index into the integer returned by analyze text. So let's fix analyze text to return the proper tuple. This fixes our new test, but we find we've broken an old one. But that's easy enough to fix because all we need to do is account for the new return type. And now everything is passing again. Another thing we want to test for is that analyze text throws the correct exception when it is passed a non-existent file name. Here we see the use of the assert raises assertion. This assertion checks that the specified exception type, in this case IO error, is thrown from the body of the with block. Since open raises IO error for non-existent files, our test already passes. Finally, we can see one more very useful type of assertion if we write a test to verify that analyze text doesn't delete the file, a reasonable requirement for the function. Assert true simply checks that the value passed into it evaluates to true. There is an equivalent assert false, which does the same thing, but for false values. As you might imagine, this test passes already as well. So now we've got a useful, passing set of tests. This example is small, but it demonstrates many of the important parts of the unit test module. There are many more parts of unit test, but you can get quite far using just the techniques we've seen here.